Welcome to Lesson 2 in Unit 19, Sensing Tsunamis. In this lesson, students will work to answer the question, what is a wave? In this lesson, they will use slinkies to explore how waves are formed and investigate patterns of wave structure and energy transfer. Students figure out that tsunamis are large waves. Waves are formed by a disturbance that transfers energy through a material. Waves are regular patterns of motion with similar structure. Waves have an amplitude and a wavelength. Students make connections to the storyline by adding additional science ideas to their model of the Japanese tsunami and consider how understanding wave structure could help us better prepare and respond to tsunami events. There are several opportunities for ELA and math cross-curricular connections throughout the lesson. You can look for specific standard connections in the Unit 19 Teacher Guide. This lesson will take approximately 3 to 4 days to complete. For the engage portion of the lesson, you'll ask students some questions about waves and revisit the driving question board. You'll add any new questions and highlight others connected to the learning goals of this lesson by calling attention to questions about what waves are and what causes waves to form. For the explore portion, you'll set up and carry out the Slinky investigation. Prior to class, you'll prepare the materials for students. See the tutorial for this activity linked in the teacher guide. In the explain portion of the lesson, students will engage in a class discussion. You'll invite them to gather and analyze their observations around the Slinky investigation. You'll use the provided questions to guide the discussion around what is a wave. The goal of this class discussion is to have students share their observations about the Slinky investigation. You will use the discussion to create the Lesson 2 summary chart. From the discussion, students should understand that if we understand what waves are, how waves form, and how they transfer energy, we can understand the strength of a tsunami and begin to explain what might cause them to form. During the explain discussion, you'll use the Parts of a Wave guide and the Waves on a String tutorial, which provide guidance on how to use interactive direct instruction using the PhET wave simulation to introduce key ideas about waves. This is where students will be introduced to the key vocabulary and apply this back to their Slinky investigation. There is a tutorial video embedded in the curriculum slides to teach you as the teacher how to use the simulation demonstration with students. During the discussion, you can post the energy transfer, disturbance, wave, peak, amplitude, and wavelength vocabulary cards. You'll have students add in the terms energy transfer, disturbance, and wave to the Part 2 diagram in their Slinky Investigation student journal page. You'll also encourage them to add parts of the wave and identify where energy is present in the diagram based on which parts are moving. You'll also provide time for students to revisit their investigation and check their Slinky model, ensuring that they have labeled amplitude, peaks, wavelength, disturbance, and energy transfer in their Slinky Investigation student journal page. You'll then have students complete the Slinky Waves quick check. For the elaborate portion of the lesson, you'll ask students questions about what they've learned about waves and how they can add to their model of the Japanese tsunami. To do this, you'll ask students what they've learned about so far they might want to include in their models. You'll have students revise their initial thinking by developing a second model on the Model of Japan Tsunami student journal page. You'll have students work in small groups and use the Model of Japan's Tsunami rubric and peer feedback table tent cards to provide feedback to each other on their models. You'll circulate during this time to also share feedback. You'll then bring the class back together and ask students to share out the differences and similarities in their models. Based on their discussion, students should revise their models to reflect feedback. To support student sense-making across the unit, orient students back to the driving question board. Ask them, what did we learn about what a wave is? Do we have any new questions to add to our driving question board? By the end of this lesson, students will have used a model to describe patterns in wave structure and how energy transfers through waves, revised an explanatory model of what causes tsunami waves to form. In Lesson 3, students will investigate how waves travel in water and how earthquakes and volcanoes can cause tsunami waves to form. For the optional extend, you can investigate how a slinky can be used to model earthquake waves. You can put students into pairs and pass out the slinkies and have them model P waves, S waves, and Rayleigh waves according to the steps provided. You can show a video that shares information about seismic waves. For more information about this unit, visit myscipartners.com.